Okay, this is exam 2 for physics 201, fall 2014. In the multiple choice here, it just had 14 questions instead of the 15, but it still counted 30 points. So I sort of had that 2-point curve built in. Let's start with number 1. Here I have two vectors, A and B. What is A minus B? Well, A is already drawn for you. And then minus B is going to be opposite direction like that. So this is negative B. So A minus B looks like that. So that's A. Which of these are vector quantities? Not mass, not distance, velocity, and acceleration. That's B. Which of these plots represents the y component of an object launched from the ground at an angle and returns to the same y position? That looks like this. All right, here my velocity in the y direction is initially big. It gets smaller and it goes to 0, and then it's smaller in the negative direction and big in the negative direction. So if I were to plot Vy versus t, it would be big and positive, 0, big and negative. So it should look like this, which isn't one of these options. So E is the answer. Given that a plus b equals c and a squared plus b squared equals c squared, how are vectors a and b oriented? Okay, well, this is the Pythagorean theorem. That means that the two vectors must be oriented perpendicular to one another for the Pythagorean theorem to apply. So A is the right answer. Cart is pulled along a horizontal track by an external force and accelerating. A cannon on the cart fires straight upwards. After it's fired, what happens to the ball? Falls behind the cart. So here, my cart's traveling along. Let's imagine that it's just traveling at a constant velocity first, and then there's a cannonball. It's also traveling at that velocity. The cannonball goes up, and then it comes back down, and in that time, the cart has traveled the same x distance as the cannonball. However, if it's accelerating instead, the cart actually zooms up faster, and the cannonball falls behind the cart. Which of these projectiles remains in the air for the longest time? Well, the y motion dictates how long it's in the air, and so the one that goes higher has the longer hang time. You run out of gas, you and your friends have to push a car out of the road. Which of these statements best explain why it's difficult to move the car? Right, it's not because the car has a big weight. Okay, that would explain why it would be difficult to lift, but not to push. It doesn't experience a large frictional force. In fact, when we watched this video, you recall, from Veritasium, where it was actually quite easy for them to push the car because there wasn't actually a large frictional force. But the reason is because it has a lot of inertia or a lot of mass. And obviously this isn't true because most of you are stronger than me. So, so a karate chop delivers a force of 3,000 newtons to a board that breaks. The force that the board exerts on the hand during this event by Newton's third law is equal and opposite 3,000 newtons. Consider a block that is rests on an inclined plane. Which of these best describe the normal force? Okay, well, the normal force is the y component of the weight. So the weight is here. It's the y component of the weight is the normal force. So that means that the normal force is less than the total weight because it's just a certain component of the weight. Okay, you push a mass with a certain force and the mass accelerates at 1 meter per second squared. And then I push another mass, I'll call this M1. This is M2, and this goes at 3 meters per second squared. That means that this mass is 1/3 that of M1. All right, so if I put them together, M1 and M2, which is going to be 1 plus 1/3 of the original mass, M1, what is my new acceleration? Well, up here, I had F equals ma, and I had 1 meter per second squared for a given force. That's for M1. All right, given the same force, and now 1 plus 1/3, that's 4/3 of M1, I have to have 3/4 of my original acceleration, which is going to be 3/4. So 3/4 is the answer. Cart on a horizontal frictionless table, once it's pushed and released, it will continue at a constant velocity. That's if it's purely frictionless. There are no forces acting on it. The normal force is always perpendicular. Mu s is almost always greater than the kinetic frictional force. And here I have a certain force equals ma, simple calculation here, 20 newtons equals 10 kilograms times a, so a is equal to 2 meters per second squared. D is the right answer. Okay, now the free response. have vectors A and B that add to give the vector R, 5.83 meters at 31 degrees above the x-axis. Magnitude of A is given. What are the magnitude and direction of B? Okay, so first of all, I want to find Rx and Ry. So Rx is equal to, what's my magnitude there, 5.83 cosine of 31. And that's equal to 5 meters. And Ry is 5.83 sine of 31. And that's equal to 3 meters. All right, so my x and y components of R are right here. All right, oh no, it goes a little bit further. This is 5 meters. Oh, sorry. My x component is 5 meters, and then my y component is 3 meters. Okay, now with that, I know that A, the vector A, makes up a portion of that, and then the remainder is going to be the x component of B. And then the y component of B will be right here. So I can say that Bx then is equal to 5, that's Rx, minus 2.17. That's 2.83 meters. And then, of course, By, the vector A had no y component, so By has to make up all of the y component of the vector R. It's going to be equal to 3 meters. Now, if I want to find the magnitude of B, I use Pythagorean theorem, and I get 4.12. And to find the angle, theta, which is this angle, I do the inverse tan of the y over the x. Let's see, the y was what, 3? Yeah, 3 over 2.83. I get 46.7 degrees above the x-axis. That's the answer. All right, a stone is thrown outward from the top of a 20-meter high cliff with an upward velocity component. That is the y velocity. The y component velocity of 10 meters per second. Okay, so here I have this cliff. It's thrown. It looks like that. I know that this distance is 20 meters. I'm going to let my initial y naught be 0 and my initial x naught equals 0. That's going to refer to this location. And I know that the y component of the velocity, that's v naught y, the initial velocity, is 10 meters per second. Okay, I don't know theta. I don't know v naught x. I know that ax is equal to 0. Ay is equal to negative 10. And I think that's about it. Oh, and I also know that the x range is 100 meters. So x equals 100 meters. My first order is just to find how long it's in the air. In order to do that, I'm going to ask, how long does it take to get from y equals 0 to y equal negative 20? All right, so I'm going to be using this. Y equals y naught plus v naught yt 1/2 at squared. That's negative 20 equals 0. So that cliff 20 meters high. Now equals 0 plus v naught y. And v naught y here is given 10 meters per second. Minus 1/2 of a is 5t squared. I need to solve this equation. I'm going to write it in the form of the quadratic. That is 5t squared minus 10 minus 20 equals 0. 10 minus 10t. It's going to be my A, my B, and my C. And then t then is going to be negative b, that's positive 10, plus or minus the square root of b squared minus 4ac. Minus 4 times negative 20 times 5. That's 4ca actually. All divided by 2a, 2 times 5. All right, that's going to be 10 plus or minus square root of 500 divided by 10. And I find that that time is 3.2 seconds. Here I actually get two answers, and I just don't give the negative answer. So I just do 10 plus root of 500 divided by 10, and that's 3.2 seconds. All right, so that's the answer for part A. In part B, I want to know if x is equal to 100 meters, what is the angle? All right, well, I know that x is equal to v naught xt. That is v naught cosine theta t. All right. I also know that v naught y is equal to v naught sine of theta, and that's equal to 10 meters per second. All right, so I have this expression, this equation, and this equation, and I have two unknowns in each. I have v naught, and I have theta. All right, so I'm going to solve that by a system of equations. I'm going to say that v naught equals 10 over sine of theta, and then I'll plug this in over here for v naught. Now, carrying on, I'm going to go and put in my value for x, which is 100 meters, equals 10 over sine theta cosine theta times t, which is 3.2 seconds. Okay, now I have 10 over 32, excuse me, 100 over 32 equals cosine over sine. And I gave a little hint over there that this is the same as 1 over tan theta. Right, sine over cosine is equal to tan theta. Oh, there's the hint right there. So then solving for this, I get tan theta equals 0.32, and so theta is the inverse tan of that, which is equal to 18 degrees. So that's the answer, 18 degrees. And I think there's a part C to that one. Oh yeah, what is the magnitude of the ball's velocity when it reaches the ground? Let's do that up here. I'll do it in red to differentiate. Okay, so first of all, I want to I know that the magnitude of that velocity at the ground is going to be equal to the square root of Vx squared plus Vy squared. It's going to have an x component and a y component. And I know that Vx is going to equal V naught cosine theta. Okay, I now know that theta is equal to 18. I need to find now V naught. If I go back down over here, I already had an expression. V naught is 10 over sine of theta. Or you could do 10 over tan 18. So I'll do that. Oh, that's not right. And I get 31 meters per second. All right, that's just Vx. And then Vy is going to be equal to V naught y plus Ayt. That's going to be 10 meters per second. That was given in the problem. Minus 10 times 3.2. 10 minus 32, or negative 22 meters per second. And then, so we're looking for the magnitude. So we say V, the magnitude of the final velocity is 31 squared plus 22 squared. I get 38 meters per second. And that's the right answer. It's just asking for the magnitude, not the direction yet. Okay. Okay, now problem number 17. I have this block. I have two blocks that are sitting on surfaces like this, this block, the 20 kilogram block, is sitting on an inclined plane, and the 10 kilogram block is sitting on a horizontal surface which sits above the inclined plane. They're connected by a rigid rope, or an inelastic rope, it doesn't stretch, that is, that goes over a frictionless pulley. I have the masses there. They both have coefficients of friction of 0.1 between the blocks and the surfaces. And I just want to know, what is the acceleration? All right, I know that the way they're situated, the acceleration here is going to be in that direction, and the acceleration up here will be in that direction. It'll have the same value. I also know that there are some tension forces. I have a tension force here, Ft, and because this is an inelastic rope, this is also going to be Ft. That same tension is felt all throughout. Let's go ahead and draw the rest of the vectors for the M2, the topmost one. I have Fn. I'm going to call this Fn2 to differentiate it from Fn1. This is going to be Fw2. And then I'll also have the force due to kinetic friction. I'll call this Fk2. Now, while I'm over here, I'm going to go ahead and write the systems of equations here. Let's draw my coordinate system. That's my x-axis. That's my y-axis. I'm not going to redraw it because, well, they're all on the x or y axes. So I have the sum of the forces in the y direction. That's going to be Fn2 minus Fw2. That's going to equal MAY, but AY is equal to 0 in this case. So it's not moving in that vertical direction. So I say Fn2 then is equal to Fw2. So Fn2 is equal to M2 times G. That's 10 kilograms times 10 meters per second squared, which is 100 newtons. So that's my normal force. Now let's go ahead and do the sum of the forces in the x direction. See what we get there. I have Fk2, the positive x direction, minus Ft equals M times A. I have to be careful here. A lot of you made mistakes actually where you put a positive A. Actually, I should have a negative A right here. M times negative A. Then I have two unknowns here. I have Ft and I also have A. I also don't know Fk2, but let's go ahead and find out what Fk2 is, and then we'll come back to this equation in just a bit. All right, so I know that Fk2 is equal to mu2, or mu k rather, times Fn2. I've already found Fn2, so that's going to be 0.1 times 100 newtons, so it's going to be 10 newtons. And then I can take that and say that this is 10 newtons minus Ft equals 10 times negative A. And I'll come back to this equation. We'll call this equation 1. All right, but notice it has two unknowns. Okay, now let's look at the next. I'll draw these in blue. I have my weight here, Fw1. I have my normal force, Fn1. And I have the kinetic friction, Fk1. I can draw my coordinate system. This is my y-axis. This is my x-axis, noticing that this angle is 60 degrees. And then if I redraw this over here, I have Fn1, Ft, Fk1. And then I have to break my weight into its x and y components. Fw1 cosine of 60, Fw1 sine of 60. And then I can write my systems of equations here. So I say the sum of the forces in the y, just like I did before, that's going to equal 0. That's Fn1 minus Fw1 sine of 60. is equal to 0, so Fn1 is equal to Fw1. Let's see, this is a 20 kilogram block, so 20 kilograms times the acceleration due to gravity, 10 meters per second squared, times the sine of 60. That's equal to 173 newtons. All right, so that's my Fn1. And then while I'm here, I can go ahead and find out what is my Fk1, because I know that it's just mu k times Fn1. That's going to be 0.1 times 173 newtons, which is 17.3 newtons. So that's my Fk1. Now I can look at my sum of the forces in the x direction. I have Fw1 cosine 60 minus Ft minus Fk1. That's equal to m times a. Now notice here that my acceleration is in this direction, and that's in the positive x direction. So whereas in the first, or the topmost block, it had a negative acceleration, and I included that negative, this has a positive acceleration. Okay, so let's see what I know here. I know that Fw1 is 200 newtons. Times the cosine of 60 minus Ft, which I don't know, minus 17.3 equals to 20 kilograms times A. This should be M1 right here. Okay, so this is going to be 100 minus 17.3 minus Ft equals 20A. Let's see, 100 minus 17.3, what's that, 82.7? I'm going to call this equation 2. Okay, now I'm going to take equation 1. I'll rewrite it down here. I have this 10 minus Ft equals negative 10A. I have two equations here. I'm going to solve this one right here for Ft. So I get Ft equals 10 plus 10A. I'm going to take this and I will plug it in up here. And so I get 82.7 minus 10 minus 10A equals 20A. And then I can solve this for A. Let's see, I get 72.7 equals 30. A, divide both sides by 30. And I get A equals to 2.42 meters per second squared. And that's the correct answer. That's the acceleration of both blocks. All right, I have one more here. This one's a little easier. I have a force of 20 newtons applied 30 degrees from the x-axis. The coefficient of kinetic friction is 0.1. And what is the normal force, and what rate does the block accelerate to the right? Let's first just draw all the forces. I have my weight, and I have my kinetic friction because I know that it's moving to the right. Now I can draw these on my coordinate system. This is Fk, this is Fw, this is going to be F sine of 30, and this will be F cosine of 30. Okay, now I just want to know the normal force. To find that, I say the sum of the forces in the y direction. That's F sine of 30. Oh, yeah, I forgot my normal force here. I have a normal force as well. So do the sum of the forces in the y direction, F sine of 30 plus Fn minus Fw equals 0, because it's not accelerating in the y direction. And I have F is 20 sine of 30 is 10 plus Fn minus 100 equals 0. So Fn equals 90 newtons. Okay. Then from this I can say, well, Fk then, which is mu k times Fn, is 0.1 times 90, or 9 newtons. And then to answer part B, I say the sum of the forces in the x direction, which is going to be F cosine of 30 minus Fk equals ma. And I'm looking for the acceleration. So this is, what was my force? 20 cosine 30 minus 9 equals 10a. Divide both sides by 10. And I find that a is equal to 0.8 meters per second squared. And that's the right answer. All right, that's the end. There are the multiple choice answers.